Hi guys, and welcome back to part 4 of this talk on algebraic expressions. Still Mr. G here. I hope you are well and keeping healthy, staying indoors, okay? Cool. Now, let's have a look at this. We are continuing with analyzing algebraic expressions. I have brought the same expressions, but just with a slight change as we get into the second part of the analysis. Here, of course, we know the coefficient, okay, coefficient of x is 5. The variable is x, and actually the constant term here, guys, is actually 0. It's just that we can't see it. Yes, that's it. So this is actually plus 0. And when you are adding a 0 in mathematics, you don't really write it, but it's always there. Actually, that's something that you guys should always know. You should have this at the back of your minds, guys, that if you see any number 2x, know that there is a 0 added to it. If you see a number 2, you must know that there is a 1 being multiplied by that number. If you see a number, any number, x or y or z or p, you should know that actually there is a 1 as a denominator of that number. This is what, guys, Mr. G calls invisible math. Invisible math. You must know this invisible math. It is very important, especially as you go up the grades. It becomes very, very important. Anyways, that was just an extra source to what we are discussing today. Here, you can see the coefficient is 3. The coefficient of x squared, by the way, is 3. Now, a new word that I'm going to introduce to you today is degree of an expression. Yes, there are degrees in maths, guys. I'm kidding. Polynomials, guys, have degrees, okay? Polynomials have what? Degrees, okay? Now, you must listen to Mr. G very carefully. If a variable has an exponent 1, like this one here, that's part of invisible math, by the way. Maybe I should note it here. Also, the variable x actually has the exponent 1. We just don't write it. Okay. So if a variable has this here, and that exponent, we say it has degree 1. So degree of this expression is 1, the degree of the first expression. The degree of the second expression is 2. Degree 2. Okay? The degree of this third expression here is 3. And the degree of this fourth expression here is 6. Now, in case you're wondering, I'm glad you are asking, Mr. G, what about the 5? What about the 4? What about the 3? Or what about the 1 here? Good question. When we look at the degree of an expression, we look at the highest exponent or the biggest exponent. The biggest exponent tells us the degree of an expression. That is one important thing that you guys must take from this. Okay, now I had said if there are 3 terms, this is a special polynomial, and so we say it is a trinomial. Okay, if there are 2 terms, we said it's a special polynomial that we call a binomial, and if there's 1 term, we call it a monomial. Now, let us look at this. I want to show you something very, very interesting, and then I will be basically a little bit done, so to say, with the language. Then we will do other more interesting stuff. If we look at this expression down here, in fact, let's look at expression 3. There's something that I wanted to teach you here. If you look at this, The constant term here, guys, the constant term here is -4, not 4. Yes. You'll be surprised, huh? What do you mean? It is important that when we look at terms in an expression, we also consider the sign of the coefficient or the constant term. The point is, consider the sign or the operation next to that term, on the left of that term in particular. So in other words, if we look at this expression here, the coefficient of the term, or rather of x, is -2, not just 2, is -2, guys. But the coefficient of x cubed is what? 1. Yes, that is very important. Why do I say that? Because of the invisible math. Remember the invisible math, guys. If there is a number, remember that there is a 1 attached to that number. So the coefficient of x cubed there, it is actually 1. It is there, guys. Finally, let us look at this. This is the cool part. Now, if I continue with this pattern, I can see that the exponents are actually decreasing in the order of 1. Okay, so I can know for sure that whatever is going to happen next, there's going to be an x squared. The coefficient can be any number. And after x squared, there's going to be an x to the exponent 1, if you like. And after that, there's going to be an x to the exponent 0. But our laws of exponents, remember, they tell us that anything raised to the exponent 0 is 1. So in other words, actually, this term here is 1. Not 11, sorry, is 1. Now, what are we learning? We are actually learning something very, very interesting. That this constant term, let me circle this constant term so that you can see it. This constant term of -4, this is what we learn from here. This constant term of -4, actually, somehow, it is constant because the degree of x, or the exponent of x, is 0 there. So you look at this as, oh, there's actually -4 times 1, and so it is -4. But anyways, this is not so important. It's just that little sauce that Mr. G thought should add. Guys, I will leave it here. In the next video, I will bring some more other interesting stuff, and I'll give you an exercise to try. Cheers.